So let's start. So this session is about Windows and SSH. You will see that you have all the slides on the Indico. So the first thing I will ask everyone to do is to be sure that you have your SSH key ready. So if you don't have it, you can go on the CC website. So I will show you just in case. Type CC on Google. And you see here, create and manage an account. Click on OK. And then you fill your email address here, and then you follow the instructions. That's it. You need to do if you don't have yet receive an email with a private key on your email. Then my colleagues on the back here will check that everything is OK on your request. And you should be able to have your SSH key when basically we're going to need it during these lectures. So, this being said, let's start. So what I'm going to discuss today is mainly three parts. The first one is overlap a bit with what you have learned yesterday. Is a bit of cluster presentations and basically a bit more in details about how the cluster is organized and basically what that means on which machine you can connect in order to interact with the computer. Then I will go very quickly on what I call SSH theory, which is mainly saying what is a public key, what is a private key, how you use them to connect. And then the main goal of today is, of course, to be able to access to a cluster. So that means use SSH to arrive on our machines so that we can use them. And here, I already present you how to get your key. So that I already just done 2 minutes ago. But then I will show you how you can configure on your Windows MobaXterm and also Visual Studio Code, so you can also edit files easily. And you basically have two solutions here. You can use the one that fits your needs the best. So what is a cluster? So we have one login, and that gives you an access to a cluster. And basically, with that login, we have access to around 10,000 cores in total. So we have 4 clusters available, T2 clusters. We have Lemaitre 3, NIC5, Hercules 2, and Dragon 2. They were all introduced yesterday more in details. And then on top of that, if you don't have enough with those tier 2 clusters, you have access with the same login to a tier 1 cluster, which is, was also introduced yesterday. So if you don't have enough access, enough CPU or enough basically flops for your applications after all those clusters available, then you can go one level above at the European level, praise typically, and that's typically competitions where you have to submit a project saying, okay, I need that many CPU hours, or that many flops, and that for that applications, that's interesting for that, and on top of that, you need to prove that you can use those hours efficiently. They're saying, oh, my code scale like this, like this, like this. So big applications, but then of course you have millions and millions of CPU hours available if you win one of those competitions. So as you can see, we have a lot of machines available for you. And of course, what you cannot do is basically connect on all of those machines and submit jobs on those machines. So that's not the way it works because we have many users on top of that. So we are not one user who can access those 10,000 cores on your own. So what we have, we basically have what we call a job scheduler. So basically you give us a very simple contract, which is I need 2 machines, 5 machines, 10 machines, and I need that many memory. Basically you describe a bit what you need. I will give you a small demonstrations today, and then there's Dania who's going to give you a full lectures on all the possibility of Slurm later. But that's basically the idea. You just have to describe very quickly what your job is, how long, memory, and all the small technical details. And then you give that to a scheduler, and that's basically someone who's just saying, okay, now you can run on those machines, those are available. Now you have to wait a bit, and that's just a scheduler, basically. So in order to do that, you need to connect to one machine. So everyone is connecting to one single machine, what we call the front node or the user interface. So everyone is connecting on actually for those on 4 machines. And that means if you run something heavy on those machines, I mean, those are big ones, but I mean, there are sometimes like a 60 core available. So they are big, but if you have 100 users connecting on them and everyone is trying to use 100 cores, then of course that machine will be extremely not responsive and not working. So that's basically the deal on that machine, that it's available for you. That's the machine on which you can basically tell Slurm, I want to run this. But that's the machine where you cannot compute anything. It's really there for editing your files, make some small make files, some compilation, some small stuff, but don't run anything heavy there. If you run something heavy and you catch it, we'll delete it directly without any warning and stuff like that. I mean, if someone runs something heavy there, basically all the cluster will start to be slow. No one can work anymore. So as soon as we detect that, or we receive an email, someone complaining that's happened sometime, or I cannot work anymore because that guy is using all the CPU for 1 hour. Then we go there, we kill, then you send you an email, obviously, but everything will be lost anyway. So that's not a node for working. It's really a node basically to submit jobs, to control what's going on, to edit files, to work a bit. But I mean by that working, I mean editing file, checking that everything is fine and stuff like that. Not running your computations there. So each of those machines are accessible, and those are the name of the machine. So that's important basically for later, because when you say, oh, I want to connect on a cluster, you need to specify the address, and you have those 4 addresses, one for Lemaitre 3, one for Nick 5, one for Hercules, and one for Dragon 2. So those are important information, so we'll rewrite them later when we go to the exercise of how to connect to those machines. Of course, what you need to know is basically the address where you go, and that's exactly what it is. However, that's not as simple as it is, because for security reasons, you typically cannot connect directly to those machines. So we need to go through a gateway, which is kind of a virtual network, if you want. It's just that for security reasons, we want that everyone that connects on those machines here first connect to a gateway which is ultra secure. So that's basically one of the most secure machines that we have. And then the only thing you can do on those machines, that technically depends on the clusters, but typically you can not even stop there. So the only thing you can do is to say, prove your credentials, and then redirect your traffic to the cluster that you want. So on some of those gateways, you are also allowed to stop there. That means open a terminal, do ls, copy files, and stuff like that. But you typically have extremely small quota on those machines, so you typically cannot store huge files there. But on most of the machines, you cannot even stop there. So you can just say to your network, go to that machine, prove that I'm who I am, and then you can redirect. So that's mainly for us. I mean, for you, it's more burden, obviously. For us, it's useful because for security, we know that everything goes through here. So if we have a security issue, we block that one, and we know that no one can connect us anymore. So that's very practical for us, great for security reasons. For you, that's give you security, obviously, but otherwise, it means more configuration and stuff like that. So the way you connect to that gateway slightly depends on the cluster, actually. No, not the cluster, slightly depends on your university. So that's why here I put, there's one gateway per university, and now I need to present how you connect for each university. So from which university are you? Are you UCL?
University Liège.
Liège. So let's start by Liège then, which is not even the second one, so it's the third one. Okay. So Liège, if you are from your office, then it's relatively simple. From your office, you can connect to the gateway of Liège, the address will be later, and then from there, you can basically go anywhere. If I'm correct, I don't know all the gateway full details. I think you cannot stop there physically. So it's, as I said before, you can only redirect your network, you cannot stop directly. If you try to connect to that machine, you will say no. You will say, no, you are not configured or whatever. That's perfectly normal. It's just meaning that you cannot stop here for security reasons. So from which university are you? UCL, so that was the first. So UCL is everything goes to the gateway port. So whatever you are, either in your office or at home or abroad, if you are maybe in the middle way of China, you might have some problem to connect that machines. But otherwise, basically, if you are even in a university in China that you work, you go to the gateway and then you connect. So that's the simple case in a way. For UAV, it's also the same. So everyone goes to the gateway, either from your office or your home. Namur is a bit different. I mean, basically, it's the same in the sense that everyone needs to go to the gateway. But there's a big difference for Namur, is that you do not connect on the gateway with your CC account, but your university login. So that's a different login here. But it's even more secure because you have two proofs, completely different proof of identifications. But for the gateway of Namur, that's handled by the university. So sometimes it can take a bit longer actually to have access to the gateway compared to the clusters. Simply to that. But that's the difference. You have your own, your specific login, university one, so I guess it's not be too difficult for you to connect to the gateway. And that's a different login to connect to the cluster, where it's all CC login there. And then Namur, like I said, Namur is a bit different. They don't have a real gateway. So the way we use Dragon 2 itself as a gateway for the other clusters. So you can connect to Dragon 2 from the office directly. And then if you are from home, you need to use the VPN of the University of Mons to connect to Dragon 2. And from Dragon 2, then you can connect to the other clusters. You cannot connect to the other cluster directly. You still need the gateway, but you use Dragon 2 as a gateway. So it's a bit a mix. They prefer it like this in Dragon 2. Okay, any questions from here? So the two steps basically is that you are somewhere, typically, except if you need the VPN, you can connect directly. Let's do that one. You can connect directly to the gateway, maybe through a VPN. And then from the gateway, you can select which cluster you need. So you need basically two steps to connect. And we will see that later. That we always need to put two addresses, one for the gateway, one for the front node. And then finally, you will arrive in the front node. And then you have access, not directly in a way, but you have access through Slurm to all those nodes. Okay, any questions? Yeah, we put the chat actually. Okay. That I already said. Yeah, so that is the descriptions of the gateway. As I said, that's machines which are completely useless for you, in a sense that you can either never connect to them, or if you can connect with extremely small quota, extremely small CPU. So basically, it's really just a gateway, just go through, but there's nothing to do there. And that's the address for each university. And that will be useful later, and I will put back in the slide later. But they are basically all the same. It's JWCC dot, and then you have the university name, either of the entity, which in our case is CISM, or the university for UAV, and also the university directly for Liège, the university directly for Namur, and of course, Dragon 2 is directly the cluster itself. Don't worry, you don't need to know those names by heart, obviously, but they are important, obviously. Okay, so now that's what I've described so far is really what is the cluster and what are all the steps that you need to go to the clusters. So now I will switch my gear a bit, and I will be much more generic in a way, so that could apply to any cluster in the world. This part is basically what is SSH. And there are three concepts in SSH. One is the public key, the private key, and the passphrase. So that are the three main stuff that you need to understand a bit. You don't need to be expert, obviously. You can use them without understanding anything of what you are doing. If we want you to be a bit secure in the way you use SSH, I prefer you to know a bit what it is. So basically, the public key is just your entry point for the cluster. So the cluster has that file, and you have it as well, actually. But that's basically a file that's proving that it's you. So basically, it's basically a key hole, and that you are supposed to be the only one with the key. And therefore, one key hole corresponds to one key, and each user has its own key hole on the cluster. So that's basically what's open the graph, and that's what is the public key. So you can have technically the same public key on multiple cluster. That's what we have in CC, obviously. We have for each cluster, you have your public keys there, so that you can access to all the cluster and all the gateway. Actually, one gateway per user. Then you have the second part, obviously, the key itself, and that's the private key. So that's something which is, of course, private, because if someone has a private key, that means they can enter anywhere, do all the damage that they want on the clusters, And obviously, we don't want two users with the same key, so that's something you cannot share with anyone. So you need to keep it secure, like it's your own. You don't give your key to someone else. In practice, you do, obviously, but for the moment, I mean, but for the cluster, it's really important that's a key for you, and there's no good reason that you need to share the key. If you think there's a good reason, come to us. You say, oh, I need to do that, that, and that. What can you offer us? And we'll find solutions, but don't give the key to someone else. And I mean, one practice that we've seen on the clusters, and we fight against, is that some people give the key to someone else so that they can submit on two accounts, they have more privilege. That's, of course, not allowed. That's annoying everyone else. And then there are always a point where someone will notice that, and will need to block your account, discuss with you, find a solution, and stuff like that. This is not allowed, obviously. Private key, as the name is said, it's private, should stay on your laptop, and that's it. And finally, to avoid that someone who's open your laptop has access to all the clusters, what we do, we protect the key and we put it in the safe. So in a way, I would say my key here is not protected. Anyone who take my key, he can enter, obviously, so that's not really safe. If I go away in abroad, typically not, but I put my key in the safe. I block the safe with a password. It might not be very secure in an hotel, but okay. But that's allowed basically to protect that. And here, that's exactly the same idea. The passphrase is basically a way to put the key in the safe. So one thing is important, this is not a password in the classical sense. This is really something which is local, and we'll see that a bit later. What I mean by that is, it's not you going on the server is going to ask you a password that he has already, and then he's going to check. That's not what's going to happen. You have in your laptop the safe and the key is blocking the safe. When we need to go and connect, what you do, you open the safe on your laptop. That means everything's there on your laptop. Then you take the key, which is decrypted thanks to your passphrase, and then you send it basically on the clusters. So the passphrase itself always stay on your laptop. It's never communicated on the web. That's also a good security point to find. And of course, when the key is sent on the web, that one is encrypted by a lot of protocols that it's not clear that anyone cannot take your key, obviously, during that time. But that starts to be too technical to my point of view. So three concepts: public key, that's what's basically allow you to enter. Private key, that's your proof that it's you. The passphrase is to keep it secure, and that's basically it. So the way we do it, and that's not the most secure, you can say, way, but to help you in the way to create those, what we have created this website. So we have this website, you enter basically your passphrase. What we're going to do is going to send you the private key by email. And we, of course, have generated the associated public key, and we distribute it on all our clusters. So you can trust us. If you don't, there is always a way to say, I don't want to trust us. But basically, we send it to you by email. We don't keep any copy at all. So that's what we tell you, obviously. You can trust us or not. Obviously, we have no interest to keep a copy of it. So that means also, since we don't have a copy, if you lose that file, you are forced to generate a new one and restart the procedure, which doesn't take that long. So that's not an issue. But you cannot, I mean, if you send us an email, oh, I forget, I destroy it, I don't have in my backup my private key, we cannot do anything for you except tell you, oh, you need to generate a new one, go on the website and renew your account. And that's something you will ask you to renew your account every year anyway. So that will basically advance a bit the time for the next renewal. So we don't have any copy at all for security reasons, obviously. Okay, that I said, I'm ready in a way. So this is extremely technical, and I don't care too much about it, especially we don't care in the day-to-day life. But just to give you and tell you how it works. So the first communications, so before anything is happening, basically you are going to communicate with a cluster and basically check which type of protocol you can use to encrypt the communications. That's basically a negotiation saying, well, I have an old laptop, I cannot use the latest stuff. But this one say, oh no, I cannot use later than those ones because those are very not secure at all. And then if you have a match here, which typically you do, obviously, then you take the most secure protocol, which is supported by both. Then after that, the first thing that needs to be done is not to prove who you are, but it's actually the cluster which is proving who it is. And that's also the same, it's a public and a private key. The only difference is that you typically never receive the public key of the clusters, so you don't know how to prove these identifications. And that means the first time, especially Linux, on Windows, you might not see that. But sometimes you will see the notifications of host, blah, 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 cannot be trusted. This fingerprint is, and you see something horrible. Do you trust these connections, yes or no? And that's the first time basically taking the public key of the cluster and saying, and then you're going to say, I'm storing it, and from now I'm saying, okay, that cluster has that key, and therefore I know, and I know that I'm connected on the correct clusters. But no one is trying to basically, I mean, it's doing that on time, right? You type Fortis on Google, but if someone succeeds in not making you arrive on Fortis but on a clone, you can lose a lot of money, obviously. And that's here the same idea, we don't want that. So the first time you will see that, so the first time you can say yes. If you are paranoid, you can go on our website where we put exactly those unbeatable name, and you can check that in this case, indeed, they match. I don't know which, anyway, this cluster doesn't exist anymore, but that's really clear. That's only during the first time, it's used to be sure that everything is fine. If you see that after the first time, then it's probably better to check a bit. It might be because the cluster was reset or something like that. It's happened time to time, not very often. But most of the time it does not. So one example, a couple of months ago, one of the gateway we had some issues, so we removed it completely and created a new one from scratch. And therefore that file was changed in the process, and therefore we sent an email to everyone and saying, if you see some conflict saying, oh, this is not the same cluster anymore, you can accept, and that's no problem. So in that case, we quickly inform you. So that's okay only the first time, basically to prove the cluster is indeed the correct one. So after that, there's an operation, so that now that you know that, okay, I'm trusting the people with whom I'm discussing, we are going to create encrypted communications. So there's a huge library, it doesn't matter. But that's important that at this stage now, everything is encrypted and nothing is sending clear on any channel. And therefore, then you finish up with the host identifications to prove you send the correct public key, but then you prove you send the message to the I tried to send it here already. But then here you prove yourself. So then you send your private key, but everything is encrypted now, so there's no issue there. And then you check that everything is fine, and then after that, you have access. So a lot of theory, that's in practice nothing that you care about. The only important point for me is that you first script everything, and then after that, you do result applications, and then there's this stage of proving that okay, you're connecting to the correct person. Okay, so now we are going to the second part, actually the third part of this talk, which is mainly now, let's go in practice. Because in fact, all those concepts of public-private keys not that important. I mean, what is important is private keys still private, obviously. But what's important is to be able to connect in the cluster. All the protocol and stuff like that, no one cares really. I mean, no one of us at least. Of course, security experts do care a lot. But okay. So this I already explained, but then we go very quickly just in case. So how do you get your private key? I said there's a website, so that's the CC website. You need to click here on create and manage account. And then you follow the procedures, which typically takes a bit of time. I will not go to all the details. It takes a bit of time mainly because one of us checks every request by hand, and that's making checking that your supervisor exists, that you don't put the wrong supervisor, that you exist, and checking that you put the correct code and stuff like that. So that typically takes a bit of time, less than a day in top. And if you are a weekend, sometimes you might be unlucky and have something up to 2 days, but okay. And then you will receive that by email. After the email, in practice, less than 20 minutes later, everything is up to date. If you are very unlucky, we say 1 hour in your email, I guess. Typically 20 minutes should be okay. So for those in person here, do you have your private key? Yes, yes, yes. Do you have a private key? Oh, that's Ariel. Ah, I didn't recognize you. So do you have a private key, Ariel?
I do.
I do, good. Sorry, I didn't recognize you, actually. Okay, so what are the tools to connect on SSH for Windows? So I would say 4 of them, and I will present actually only 2 here today. The first one is the most famous one, so I'm pretty sure that everyone on Windows, might have heard about it, and that's typically the first choice. We say, oh, you can use PuTTY. This is not very common at all here, for 2 reasons. First, it only do SSH, so that means no file transfer. So you need something else for FTP or whatever to basically transfer your file, which can be okay. But the main reason why we don't advise it is because it has a bad support of key. There's another format for the key that we provide. So you will need to convert the SSH key we send by email, you need to convert to a new one. It can be done, obviously. If you want to use PuTTY, you can. But that's not something we're going to present here, and that's not something we really advise. So our recommendation is actually MobaXterm, which is actually very easy and actually support basically everything in that case. So that means connections and file transfer. So something is the first time I'm going to present it is Visual Studio Code. So it's not perfect solution. So you need to decide if it fits you or not. What I like about it is it's so it supports of course SSH, so you can create a terminal. It supports file transfer, and what is more than MobaXterm, it has of course a full text editor experience. So you're basically a full native graphical text editor on your machine, and therefore it's relatively easy to basically edit all your text and then to run them. While on MobaXterm, you need to either use some graphical stuff or use Emac or VI, which are I'm using Emac all the time, so I'm saying that very good editor, obviously, but they are a bit difficult to learn, let's say. Visual Studio Code is all graphical, so that's the Windows experience that we used to. While Emac and VI are all technology in a way extremely powerful, so that's I advise you to learn them actually, but to start it's more difficult. The only issue with Visual Studio Code is you don't have in an easy way, so it's also possible actually, like this is way to circumvent. There's no easy way to go graphical server. So that's something that personally I never use in graphical server, but if you want to open Firefox, but the Firefox is running on the server while you see the display on your screen, this is not something which is easy to do on Visual Studio Code, but it's completely native here in MobaXterm. So, but I would say the most typical, it depends on your usage, obviously, but quite often the reason why you go graphical is mainly because you want to open graphical editor, and that's of course it's not the use in this case. But as I said, you can choose whatever you want. Of course, if you use a lot of graphical display from your code and stuff like that, this might not be a good fit for you. Then it's probably better this. You can also use both at the same time. There's no problem there. And the fourth one is actually OpenSSH on Windows. So that's something relatively new. So it's 3 years old now. So I expect most laptops now support it natively. And that's actually the exact Linux experience, with small differences, obviously. But it's basically, if you go to the next lecture from this afternoon on how to connect with SSH on Linux, everything here will be basically the same. And what is nice, actually, and I will show you how to configure with Visual Studio Code everything. Visual Studio Code is actually using another hook, OpenSSH. So if you do the configurations for Visual Studio Code, with automatically SSH configure as well. So this is really a terminal-like experience, actually. Okay. So I would say time for the, well, not yet. You can do that already. So the 2 codes that we're going to install today, that will advise you, or maybe only one, is to install MobaXterm and Visual Studio Code. So those are relatively easy to install. You basically search them on Google. For MobaXterm, you download the free portable edition. For Visual Studio Code, you download what it suggests you, and that's okay. and then you can comments that execute, and that's it. And I typically don't need that, but you might need to open your firewall depending on the security on your laptop. So that's how to install. That should not be an issue typically. The only thing, download the free portable editions. There's also, you can pay with more. Typically, it's not needed. Okay, so I will give a demonstrations. So we are going to do a new sessions. So we choose SSH. And now remote host. So that's one of the cluster I described before. Of course, I kill. Maybe can I find that? Oh, it's still there. Good. So you have the remote host options here. So in this case, I will take N5, let's say. But those are the 4 options. The last one is not valid anymore, so they remove it. So method 3, N5, Hercules, and Dragon 2. So you have the full name here on the slides. The slides are on Indico as well, because maybe, yeah, no, well, at least you cannot really see them. So here we'll go to N5. Let me check the name. N5, yes. I need to specify my user. That's of course specific to everyone. So my normal user account is Matt, and the port that you don't change anything. So that is the final address where you go. As I said before, it's impossible to go there directly. So you need to go to advanced. Okay, not in this one. Oh, you need to go there as well, but let's go first in network settings. And here you have SSH gateway jump host. So it might also, of course, be slightly different display depending of yourself. And here you can basically configure the gateway. So if I go back here, okay. No, it doesn't want me to. Let's stop this. Okay. No. Here we go. Did I put the name of the gateway? No. So let me go back to the name of the gateway. Yes, here. It's basically gateway CC and then your university. So that's important. That's your university. It's not the if you are going on Lemaitre 3, you don't have to put the one of UCL. No, it's always the one associated to your university. So let me do that. So in my case, I'm from UCLouvain, so I cannot put the gateway of ULiège. I need to put, of course, the one of UCLouvain. So it's GWCC. And of course, in this case, I have to put the same username. That will be the same for most of you, but the one of Namur, we of course have to use a different username and a different type of connections. And then in this case, I have to say that I want to use my SSH key, and then I need to specify which one, which is in this case already there. So I'm selecting it where I put it on my desk, on my laptop, in this case, where I put it on my disk. And then I put OK. So here I've successfully, hopefully successfully make mistakes, make the connections to the gateway, but I didn't yet specify that I need to use for the last connections also SSH key. So you have here at the bottom, so that's in advanced SSH settings. You can say use SSH key, and you say, of course, in this case the same. Again, for Namur, it might be different keys, or in the second, for the gateway, it might be password. I actually don't know which one, but okay. And then, okay. Then it asked me the passphrase. So Okay, and I didn't make any mistakes. I'm now connected on NIC5. Yes.
So even though you're connecting to NIC5,
yes,
you use gateway from UCLouvain.
Yes.
So even I could do it even if I'm not from UCLouvain. Or...
No, in your case, you need to use the gateway of Liège because you are from Liège. So the gateway is really, I mean, in a way that allows us, I mean, first to separate all the university, but actually, yes, saying everyone's going from that gateway, we know they are going from that university. So that's, yeah, it's a way for us to, actually, yes, also to make a load balance, basically. Because the gateway are virtual machines, typically. So they are extremely light machines that allow us to basically kill them and restart a new one very quickly. That's also for security reasons. But therefore, we don't want that all the system users go on one because, I mean, then we need to scale up and stuff like that. So the allowing to have one per university allow basically to do a load balance for free. Okay, so we'll check. So that's the correct time now to check that you can do that. And yes. And then, okay, yeah, I mean, as you can see, I've already tested just to prove myself I can do it. I'm not working on Windows on my day-to-day life, actually. So actually, I have a laptop for 3 days on Windows just for this occasions. So I just tested yesterday that I was successfully doing Welcome 3. You don't have to redo that for all clusters. There is an option, which is if you right-click, you can duplicate session. And as you save all the setup, then you only have to change the name of the cluster, which is much faster than redoing all the steps. It's not extremely long anyway, and we have only 4 clusters, so it's not a big deal, but that's a nice trick, let's say. Okay. So the typical mistake I had from previous year is obviously you write incorrectly the name of the clusters. You don't put your username, but you put mine, or you don't put the gateway of your university, but you put the same as I did. So that's the typical mistake, obviously. So if you cannot succeed, especially for the people online now, if you cannot connect, check carefully that you put the correct name on the cluster, that you put your login, and that you choose the correct gateway, the one of your university. Okay. Yeah, I didn't do that. So, as I said before, compared to Visual Studio Code, here I also have, well, it's written here at the top actually, X server. So that allows us to basically send graphical stuff. Bernard showed you yesterday a couple of stuff that you can do with graphics, opening Firefox, opening text editor, and opening a clock. So here, if I can. Okay, on X is not on NIC5. Should have done that on kilometer 3 then. Xlock neither on X5. Let me go. I don't know all those X commands because, as I said, on Mac it's also not very practical with graphical stuff, so I'm never using any graphical stuff. So XM is very slow. Oh, it's here maybe. Yeah, it's here actually. It was on the background, that's why it's so slow. Well, it's a bit useless with Xterm, okay. Yeah, but what's the point of a graphical terminal if you can have a non-graphical one? Yeah. For the purpose of proving that it works, it's fine. But I don't see a practical purpose of Xterm. Yeah, that one from here, that should work. Edit. Not sure it will work, but okay. That is more practical. So the issue, obviously, with everything's graphics is typically extremely slow and unresponsive, especially like here I'm on the wireless, so it's not very fast connection. So I will kill it. So that's why typically, I mean, also I do not really recommend too much to use those graphical stuff because the user experience, let's say, it's not that great to my point of view. But as also I don't have that much experience. There might be some applications that works beautifully with that. I've never used them personally. Okay, so that is one thing like this XTerm, or if I'm going on the method tree, I know that XICE is there. Here I can do XICE. That is the most beautiful applications ever. So you see those two eyes here, and that's follow my mouse. That's wonderful, very useful at least. But just to prove that okay, that is something more. But obviously, it's so useful that we don't put on all clusters. I only put it there for the demo, and that's why it's not on big file. Okay. So let's go back to the demonstrations. So if online you have issue, don't hesitate to put questions on the chat. It's extremely important, obviously, that everyone is able to connect on the clusters, at least with MobaXterm. So if you do not succeed, don't hesitate to put a message on the chat, and there are people who are going to help you. If needed, you can create a private room here to discuss with you alone. But it's really important, obviously, that everyone is able to get on the clusters. That's the main reason of this lecture, anyway. Okay, that I will skip. Then the second step configuration that is useful on MobaXterm is what we call the agent. So it has two advantages. The issue with those keys and those passphrase is that you, of course, have to enter your passphrase very often. And also, if you try to copy files from, let's say, NIC5 to manback to the method tree, then you also have to, oh, now I need to pass my key, then you need to move your key, and it's not practical. So in order to solve all those issues, we have an agent. So it's basically someone which is going to type the passphrase in your place and going to propagate your key. So that's very practical. So here, you need to go to the MobaXterm or going to do that settings. So it's a bit hidden in my case because of the Zoom stuff. But basically on the top, you have settings. And then you go settings for SSH. And what is important, of course, I've already done it, is to put I typically put SSH keep alive. That's basically forbidding to your SSH to drop too quickly. And then there's the forward SSH agent and use internal SSH agent, which are here. So that's basically allowing MobaXterm to store, of course, in a secure way, all the passphrase that you do. So basically, write those passphrase for you. And then the forwarding, I will explain in 2 seconds, but that's allow you to, when you are on the method tree and you want to connect on NIC5, that basically this will say, oh, actually know the passphrase for that one and know the private key, and then it will propagate it from one cluster to the other. So you need to do that only if you trust all the clusters in the configurations. Otherwise, it can be a bit dangerous, obviously. So, okay. So let me explain. So the idea is that you, of course, want to have your private key to be private. And therefore, that means we don't want that the private key is on more than your laptop. Of course, if you are working on your day-to-day life on your laptop and a desktop, you can put the private key on both. But typically, we don't want that your private key is on all clusters around the world, because that basically means that the key will be less and less private the more copy you have around the world. So for the moment, if you didn't have this SSH agent, you would be able, from your laptop, with as the key, to connect on telemetry 3, on other CC clusters, and with other means, you can connect also to non-CC clusters. So that's, I mean, if you have other than CC clusters. For UCL, for example, we have other clusters here, like Mattelaer. That's one of them, for example. But okay, that means that if you are on level 3, you don't have your private key here, so you cannot connect on Dragon 2, you cannot connect on the other CC clusters. So what the SSH agent is doing, so if you are on level 3 and you want to connect on CC clusters, what's going to happen is that there will be a request for a private key for the non-CC clusters. It will be sent to level 3, will actually forward the information to your laptop, and then the information will go back with the correct private key to these clusters, and then the connection will be granted. So that's the second advantage to the agent. You don't only have to type your passphrase less, you also actually can propagate and then connect from another cluster to another cluster. So that's very useful if you want to connect from level 3 to NIC 5, for example, or other clusters like that. Yes, so that's already mentioned. One thing I want to mention, we also have between all our CC clusters extremely fast way to communicate. So we have private system of communications that allow us with, I mean, we have our own fiber, 10 gigabyte per second fiber that connects all the clusters of our different university. And that means that if you do SCP, for example, from one cluster to the other, you typically go to the normal fiber, which is slower, and that means you will take a lot of time to transfer file. So if you want to transfer file extremely efficiently between our clusters, what you can use is to write from one cluster in /cc transfer, then typically put your login, then put your files there. And that is basically a 10 gigabit transfer, and a couple of, depending on the size of your files, obviously, you will find the same path, /cc transfer, blah, 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 on all other clusters within a couple of minutes, seconds, hours, depending on, I mean, if you have a petabyte, then you need probably to contact us first. But basically, if you have large files, this is much faster than doing a normal SCP. We have dedicated sessions by Ariel, actually, in probably a month from now, I guess. It's in a month, your sessions, right? About CC storage.
Yeah.
You know, on the month. Yeah. Okay, maybe I want to do something first here. So in top of the connections, it's also important to be able to transfer file. So you can see here on the left, you have actually all the content of all the files that I have on that cluster. So you see on the Metro 3, I have quite a lot. On NIC 5, I basically, okay, I should have connected once I have a hello world.py file. So I have the files there. And it is actually simple drag and drop. So let me move this. Yes. So if I take this file and drag it here, up, now it appears on my laptop. So it's very simple to transfer file, simple drag and drop, and you can move file from the cluster to your Windows, and the opposite obviously as well. So now if I want to move it to the Metro 3, let's say, I can do, oops. And up now, I should try to find it. I have so many stuff here. Right, I can type here, I guess. Oh, it's not important where it is, but it's there somewhere. I should have put it in an empty directory so that will have been easier to find. But okay, so you have all your files and very easy communications between them. This might not be the most easier way to transfer from one cluster to the other, but just to prove that I can move stuff locally and back. Okay. So now you have access to the clusters. You have access to the only machine where I tell you you cannot do anything. So that's not very interesting in a way. You have access to the machines where, by respect for the other user, I ask you to run extremely light stuff, editing files, it's fine, obviously. Small compilations, if you need to compile for 5 hours, try to not do it there, obviously. But it's 2 minutes, it's fine. So now, basically, what can you do with that machines? And here I'm going to present you extremely short introduction to Slurm. So there will be also in around a month a full tutorial on Slurm. Why we do it so late is basically Slurm is extremely, it's an extremely complex tool, obviously. It can support a lot of different types of computations that typically you don't know at this stage. So there is computation with OpenMP, MPI. You can do, a lot of stuff. And that's why we do it at the end, where we've introduced all the types of computations you can do. But here, basically, I'm going to give you the extremely quick tutorial and basically some introductions for where you can find more information about those. So the first things you can run is to have more information about the cluster itself. These are the S-info line that I will run. So I will run it on Lemaitre 3 and also on D5. And typically what it gives you as information is what are the type of machines, what are the partitions. That's important to know the different partitions. That means where you can run. We've split in different categories. So on Lemaitre 3, for example, you can see that we have 2 partitions. One is called batch, which is typically our default, and one is called debug. You also have that batch is 2 days, so that means you can run up to 2 days on that partitions. That's the maximum time that we allow you to run it, while on debug is only 6 hours. And why you have 2 is actually, you can see here the difference. Those are different architectures. So Lemaitre 3 is MPI, actually Unique 5 as well, is MPI intended, so you intend a lot of communication between different machines. So it's important that all the machines basically advance at the same rate, because otherwise if one part of the computation is slower, it can slow down the full stuff. So that's typically why we have 2 partitions. So typically you run on one or the others. It doesn't make that much sense to run MPI on both. Depending on your application, so obviously, if you don't mind that, there's no issues. Yes? Je pourrais augmenter la fonte. Non. Contrôle molette. Contrôle molette. J'ai pas de souris. Terminal Zoom. Ah. Yeah, when you say that, I say, oh, I was understanding good, not one more time. Okay, yes. So, yes, obviously the batch partitions have a lot of nodes, 78, while the debug has actually much less nodes. So, yeah, when there was this question yesterday, a node is really a physical machine, per se. What you typically use is not a node, but a core. So a core is really 1 unit of computations that you have on the machines. Of course, on the machines, you also have not only the number of cores for computations, you also have the memory. And therefore, you also, that's the memory really per machines. So if you can say, I want to use 1 core but 93 GB of RAM, then of course, you basically think I'm taking the full node for myself. If you say I want to use 1 core and 1 GB of RAM, then Slurm will tell you there's no way that I can fit that. And you will say actually in the queue, you need to check if you, and you say why you are not going to be assigned to any machine. Say, say resource not available. And you're basically going to wait for an extremely long time that we add new machines with more RAM, which I mean, basically, you typically cancel or we cancel your jobs before that. Especially here, we're not going to add any machines on that cluster. So of course, you can wait basically any finite amount of time. On some other clusters, this might happen, that it happens, but okay, it's not a good practice to submit the jobs before the machine is available. So that gives you basically the main informations. So you have two places where you can submit on the batch partitions and the debug partitions. You see there is a star on the batch, means if you don't specify anything, it will go on the batch. And that's basically it. So if I'm doing the same on NIC 5, so you will also see that there's three partitions here. There's the batch partitions and the HML partitions and also BO partitions. And then you see the different time limits, which are 2 days for all of them, except for the BO partitions. What you might be on the some bio team, or I'm not sure if anyone can use it, which is the time limit is 62 days. That's huge. There's only one machine there, actually. And then you see, okay, that's 36 machines which are partially used, 34 machines which are completely used, and in each man we have 2 machines which are idle, which is not used for the moment. So let's give you information. So the main information for you is which partitions I can submit. So obviously, if you need high memory, that's the reason for HML. If you need a lot of memory for your jobs, you need it's better, and it's better for you, but also for everyone, that you go to the HML partitions. Otherwise, you can go to control. So that's for the descriptions of the clusters. After that, here I will go to a very simple run, which is srun minus PTI bash, which just means I want to have one core on one machine, and I want that interactively. So I open a terminal on one of those many nodes that we have available, and I'm going to do that now. Let's do that on Lemaitre 3. So srun minus PTY bash. So I'm asking basically a resource on the cluster. Anywhere on the cluster, it doesn't matter. I'm asking for one core available for me. By default, it will be on the batch partition. I could add a -p debug to be on the debug partitions. And then you see the first line is, actually I can probably do it a bit bigger again. Maybe I did the zoom on the other terminal. Is this good enough, Damien? Yeah. So you see, of course, it starts by saying, I'm queuing you. So I'm putting you in this huge request of all users. One core is a small request, so it typically goes extremely fast. And you see that maybe less than 30 seconds. In this case, I add one node that's assigned for me. And you can see here the name of the node, so it's W080. So that's one of the many machines we have. That's really physically now, if you remember, and go back to that. At the beginning, the description with many machines. So now you are physically in one of those, and you can do basically whatever you want. You have not a full amount of CPU. You have one core in this case, so it's quite limited. You have a maximum amount of RAM also available. You can ask for more or less. I take all defaults here, but you can, of course, ask if you need more RAM. If you know that you need basically a lot of RAM, then you can ask. If you want the full node only for your set, there's also options. But that gives you basically an example of how you can very quickly go to one node. And here you can do basically whatever you want, and no one will complain about that. Yes, now I need to go back. So a second very useful command, actually the third one, srfo to know a bit where you are working. The second one is srun, and I give you the most, one way to go to one machine, so what we want there. The third one is SQ, and that's allowing you to know what's going on also on the cluster. So I'm going back on the other terminal of MobaXterm 3. I guess this is not big enough. And then now I can do SQ. So SQ will tell you what are all the jobs submitted on the cluster for the moment. So all the one running and all the one waiting to be submitted. And you can see here there's typically quite a lot of requests. So all those are the pending one. And you see here, this is typically the next one is going to be run on the cluster, and it requests actually 22 nodes. So that's actually a big job because it requires a lot of resource. And then why it's not submitted yet, it's basically it's still waiting for resource. So basically, since you ask a lot in one go, we need to empty the cluster so that we can basically fit that request. Typically, of course, small requests go faster. I mean, the more you ask for, the more you are going to wait, obviously. One trick that can be very useful is to, if you can succeed to say, oh, I'm only using 1 hour of CPU time, then you can typically, even if you have low priority, you see all those ones are not submitted because they don't have enough priority. But if they were saying, I don't know how much they request, but let's say that this one is only to start in 5 hours, simply the time that is expected to empty the cluster and those 22 nodes available. But I think maybe now with 5 nodes that do nothing, just waiting for this guy to be able to add. So we're waiting 5 hours, and those nodes are not going to do anything for 5 hours. But if one of those jobs was only requesting 1 hour or 3 hours of jobs, then there is no reason to make it wait. It can actually run now, will be finished without annoying this one. And therefore, of course, we are doing that. So that's the main advantage is to ask not too long amount of time and not the default. So you say, oh, I'm only going to run 1 hour, you can actually avoid those waiting, and that those wait quite a lot. You pass before them, and that's very efficient. So that's something you have to keep in mind. If you ask less, basically you go faster, and also simply because of that. So you see here that there's a lot of information. You can also only ask for yourself. So here I think that then you have user equal me, that's work as well, right? The shortcut for where you don't have to put your full login. Dash me. Is this work? Yeah, no. Then you have to put your. I thought this was going to work, but you show me at some point some keywords that's allowing you to not put the login. But okay, doesn't matter.
Don't need to put the tag user. Just SQ there.
Ah, that's right. Okay, thanks. And then you have only the information relevant for you. So in that case, I have one job running. Actually, I'm not. I mean, I'm fully idle for the one on that job, so I'm just wasting speed time. But that's the job which is working is actually this interactive job. So of course, I'm not doing anything on it, but it's reserved for me. I can do whatever I want. In this case, I'm wasting the CPU because I'm just a terminal open and not doing anything on it. So that's not very respectful in a way. Of course, this demonstration is okay. Are we going to kill it? But in this case, just doing exit. Okay, so now it's done. I'm back, as you can see here, on the master node. And now if I'm redoing this command, I indeed see that my job is removed, and therefore this resource is now available for all other users. So those are I would say the most basic case where you can use a resource. If you go on one node, do whatever you want on the node, obviously. We have this link. So with this basically a page, we're saying, okay, give us the descriptions. It was already described yesterday, actually. But give us the descriptions for what you want to do. And we'll create you basically a script here. So if I put in, okay, I will not put that, but saying, oh, I want the GPU. I want jobs for, let's say, 1 day. I want more memory. I want 2 GPU, let's say. I mean, you can basically fill all those forms, and you will see here that you have the submissions jobs. That's what. In this case, I asked GPU, so it also tells me, no, you have to go to Dragon 2. That's the only cluster that supports this type of computations. If I understand correctly, FPS is going to have some GPUs soon, but maybe I request too much, or I'm not sure exactly. But that's allowing you to basically create those kind of scripts. You can also ask for MPI, OpenMP. I mean, you will learn that later, but that's basically the key point to how to know how to submit the jobs. And then you write that in a file. And then after that, so you copy that on your cluster in the file, and then you do SBatch, the name of the file, and then you will have your request. So that's if you need more advanced usage. Obviously, there is sessions of Damien with all details, all the trick of Slurm and stuff like that. This only to give you a small hint of what you can do. I hear that was someone we had to enter multiple times the passphrase, and that can make sense, especially because you have the gateway and then the clusters. So especially if you don't have yet activate the SSH agent, then you will need actually to enter it multiple times. So that's normal, and you have to enter basically the same passphrase multiple times. If you activate the agent, and I will show back how to do that. So that's in settings. You might see it better than me actually. So here in settings, if you click on settings, then SSH was already selected, and then you say forward SSH here and use internal SSH mobile agent. If you have those two click or validated, then in principle you will need only to enter your passphrase once per. I mean, I don't know exactly. I mean, how often you will need to re-enter it, but certainly not multiple times in a row. That's for sure. If it asks you still asking you multiple times in a row, it might be because you entered the wrong passphrase, which can happen obviously. In that case, you need to regenerate your key. So this is, I have already discussed it directly, so just telling you that you can easily drag and drop a file from your laptop to the cluster and from the clusters to your laptop. So no issue on that. And the next and last part here is basically how to edit text on the cluster. So I already mentioned that before. There are text editors available on the clusters. My favorite one is non-graphical text editor there. So the most famous one are Emacs and VI. Both are extremely difficult to learn. I would say all the shortcuts and stuff like that are not that intuitive compared to the Windows world at least, or even on the Mac world. Those are extremely, those were done much before that actually, before even Windows exists. But those are extremely powerful. So there are something, if you learn them and you can master them, then you can edit fast, edit file in extremely fast way. You can edit by color, you can select in very way, edit, search very efficiently and stuff like that. That's extremely powerful, obviously. So the second method is that the gedit method I showed you before. I tried to show you, and I canceled it because it was too slow. That's basically creating a graphical editor. So with MobaXterm, that's very practical. You launch MobaXterm, and then you can pass graphics through the bandwidth. That means the bandwidth is limitations, obviously, and it's typically extremely slow and not responsive. So that's not something I personally like that much. You can use gedit, for example, that way. You can also put other stuff, but I'm not really liking the idea. So, one solutions, if you don't want to go graphical, Emacs or VI, one thing I can do is to use Visual Studio Code. And that's a solution I've learned recently, and I like it quite a lot. So, Visual Studio Code is mainly a text editor that is normally working on your desktop or laptop directly. So actually, I already have it configured here. So installing Visual Studio Code is very simple. You can install it on Mac, on Linux, on Windows. Those are pre-compiled, so no issue on that. So you can, it's a normal graphical applications where you can open files, you can edit them. One of the main advantages is that we have a lot of plugins for it. And that means you can have a lot of plugins for Python, C, C++, any kind of text files you basically want. There is also a plugin for Git. So you have, that's another session I'm going to give later. And you can see a lot of graphical stuff related to Git. For Fortran, I mean, basically any language that you want to use, there will be extensions for cool, syntax lighting and stuff like that. Search and stuff like that. I mean, it's a wonderful tool that I'm using actually every day on that. So I'm not using on these machines, so it's not that much configured on these machines. But it's a very wonderful text for editions. So of course, by default, everything here is local on your computer. So you can take a file, if you're doing new files, I will open the files on my computer. So I can do that actually. I want to say open files, that's what. And now I can go to my desktop and open the file hello world that I was taking from the clusters, which is very simple stuff. And you see here, it detects automatically that this is Python, and it recommends me actually to install all the Python plugin that I can do. First workspace, and now I'm installing this Python module that will give me, of course, the simple print stuff. It's not very useful, but that will give me, if I have multiple functions, I click on the other functions, I'm going where it's used or something like that. So that's a very wonderful way, basically, to edit code. I have a lot of stuff on the side as well with all the functions I need. I mean, it's really a wonderful way to edit code, actually. So I'm completely convinced, independently of the SSH part, that using Visual Studio Code on your machine is much better than using gedit or any text editor. This is really for development, actually. It's not like in that you're going to write your thesis, obviously, but for code, that's really wonderful. So Python is slow to install, but that's okay. We don't really need it anyway. So here, what we are going to do is to be able to do this kind of connections. But now, instead of having the files on your machines, having the files actually on a remote machines. So that's the extensions that they can do on Visual Studio Code, and that we have all the experience and all the graphical part actually on what they call the local OS, but the files are physically remote somewhere. So how to do that? We need to add SSH for Visual Studio Code, and that's actually very simple. It's like an extension for Python. But in this case here, actually it's well, in that case it's already installed. But if you click on extension, then which is this blob actually, which in my case was opened automatically because I was on Python, you can here search, and then therefore you can search for SSH. And it tells you all the plugin it knows about SSH. In this case, what they have installed actually is remote SSH. So you click on it, you click install, and you will have it as well as simple as I've done actually for Python. You click on install, and then you know. So in this case, it's already installed. I can install it, but I will not do it, obviously. So I will give you 2 minutes for doing it, basically, and to install it yourself. As you can see, there is a lot of other tools available. That's really a marketplace where you have a lot of extensions. And you can do great stuff. So after that, you have in the bottom left, you have this green arrow, and you can click on it. And then it will say connect to host. And that's, of course, what we'll do later. But the first thing what you need to do is to configure SSH. So we already configured it in MobaXterm, so that's only configured for MobaXterm. So we cannot reuse that configurations. So what we're going to do the first time is to click on this third line, which is open SSH configurations file. And then it proposes you multiple paths. Typically, take the first one is the correct one. At least on all machines I've ever done, it's the first one. And in this case, I have already configured it. So this is a configuration file, which is, as you can see, quite long, so it's not easy to create yourself. But thanks to, I guess, Damien, or at least all the CC developers, so that's what he said. There is here a link so that you can also find that link in the documentation, obviously. So if I'm clicking here, you go to a web page where it's asked a couple of information. So the first one is which university are you? So in my case, I will put UCL. What's my login? I will put format. This is actually only asked for UCL members, so you will not always give it. So here, I put CISM in this case. You have access to tier 1, in my case it's no. And then you will see below if this file is created on the fly according to the answer that you have put here. And this is actually the configurations file that you need to put within MobaXterm. So you can copy paste all this, make Ctrl+C, go back to Visual Studio Code, and you can paste it here. The only thing you are likely to have to change, and that's what I have done actually, is to change two paths, which is this one and this one, where the paths are written by default for Unix, so you need to change them for Windows. And in this case, I put the path to where I put my private key, so that's the path for the private key, so you need to put the full path of that. And I guess you all know the path and the files on Windows. If not, I can give you online as well. If you don't know how to get this kind of path, I can show you in any case. So if I go here, let's say, I'm taking one file, whatever. I mean, okay, it's here. I can right click, go to property. What is it? Property, yes, it's in French. And then I have the path here, and I just have to add the name of the file. Okay, so that's the configuration file. So now I can save it and close it. And now I can re-click again on this green area here, and now I can say connect to host. And now automatically all the clusters that are defined in that configurations file. So you can see that propose me to connect to gateway CC, which is meaningless in this case because I actually cannot connect on that, but it's proposing level 3, Hercules, NIC 4. So here let's take NIC 5, for example. So you ask me the type of platform, it's Linux. And now it's asking me for my passphrase. I'm asking, yes. So it's the first time I'm connecting to NIC 5. So it's the same message that I was presenting you before. It's telling me, oh, NIC 5 has that fingerprint. Do you want to accept it or not? Because it's the first time from this machine I'm connecting to that machine. If I was a bit power, let's say, I would go to the CC website and check that it's the correct fingerprint. I will say, okay. And I need to enter my passphrase a second time because it's one for the gateway and one for the machine itself. And now I can do open file. And you can see actually all the files I have on that clusters. I told you that on NIC 5 I don't need that much, but I have again this hello world here. But those are really the files on the cluster itself. So maybe if I'm doing that now, a new one, connect to hosts, and doing all the metro tree because I have much more files there. And now if I do open files in this case, you will see that I have all the files that I have on my clusters on the metro tree that in this case I have quite a lot. But those are really files on the cluster itself. So let's open a fun one. So you see here on the left, I have basically pictures, small pictures of all the files that I can quickly spot. In principle, I don't have it configured maybe here. On the left, I have outline, that's the one. It doesn't have found it yet. So in outline, you can typically add all the functions and class definitions that you have in the file, but it doesn't have found it yet. I'm never sure when those occur, but it will happen at some point. You scan the files, then you write here all the functions. And that's all very practical to move forward in the file. Okay, so that's a very practical way to edit the files directly from your machines, and you edit it and you see that it's extremely responsive. So that's a very practical way from Windows or any machine cycle how to edit files on the clusters. Yeah, so this I've all done. The last stuff I want to show you, so I show you how to edit the files, but what you can also do is actually open a terminal from Visual Studio Code. Go there. I need to put it down a bit. So here you have in the menu bar your terminal, you can open the terminal. Can put it, and you see that I open a terminal now on NIC5, and I can run any Linux command I want that you learned yesterday: cat, ls, pwd, cd, make, all the functions that you from Bash. But that's also a way. So in a way, it's possible to close to completely remove MobaXterm and use only Visual Studio Code. The only thing that you are missing is if I'm trying to run Xterm, let's say here, it will crashing. I cannot open the display. So it's also possible to start on your Windows a graphical display if you want to fix that. But okay, in that case, if you need such kind of graphical display, it's probably better to go to MobaXterm. If you don't need or not very often, this is a very practical solution. The only thing, and then for that you need to be administrator on your machine. But if you want to create the agent exactly like in MobaXterm, you need to start the agent in this case, and then for that you need to be administrator, which I'm not on this machine, so I have not done it. But here I put you the information, so how you can, which command you need to run to basically set up the agent on Windows. One last comment. So basically what I have done with Visual Studio Code was actually configure OpenSSH. So now if you open a PowerShell terminal, so, I mean the command, I can also now do SSH Lemaitre 3. What's going on? And then it will ask my password, and everything is configured also to run like in Linux. I mean, if you want to do it, you can. It's not really useful, I guess, but it's also possible to connect basically like that. Yes. Just to conclude, I mean, my only guess is that you not leave this room, and I will stay here connected a bit longer. You don't leave this room either virtually or physically if you are not able to connect to the clusters. That's the most important stuff for me, obviously. You can choose the method you want to connect to the cluster. That's not important, obviously. I like Visual Studio Code a lot, but it has its limitations. But the important point is that you are able to connect. So basically, one main message also of today is when you arrive on the cluster, you are on the front node, and that machine is where everyone arrives. So if you run something every day, you will block everyone to using the cluster. So you cannot run any, I mean, that's not where you are going to run your simulations. You can run text editor, obviously, a small Jupyter notebook or stuff like that. But if you are running something which is heavy, taking multiple cores for multiple hours, I mean, and that's an hour, not an end, then you need to submit the jobs and run that on the node and not on the front end. So that's also something critical. Your Jupyter notebook, if you run that on the front, on the user interface, is that something like that's no issue if you are starting to make real computations that's taking a lot of CPU time. That's not on that machine that you need to do, but you need to do a SSH. I mean, you need to use the srun minus PTI bash that I show you to basically run that on one of the nodes. So of course, you will have a lot of CPU available, so you need to use them in a responsible way. As we discussed yesterday, there are two ways to waste it. First, you are wasting, if you are doing stupid stuff, let's run it, you are going to waste the electricity, which means that's not good for the planet. But of course, you are going to block other users to use those resources. And that's of course that you are blocking other people, and then at the end of the day, you might block yourself at the end. As I said, don't overload the front nodes, and you need to use Slurm for that. And security is of course extremely important. You cannot share your private, do not share your public keys. That's fine. You cannot share your private keys. That's a typo here. The public key you can share it. That's not a big issue. Even if you like, but that you cannot enforce that you use actually we don't give you the public key, but to not have the same public key in multiple clusters. So it's important that for each organization you have your own private key and you don't use the same private key for multiple clusters or multiple organizations. That's a law basically to have better handling later. But okay, so don't share your private key in any case. And if your laptop is stolen or whatever, of course, even if you have a backup of your private key, you need to ask us to renew your account, and so that we have a new one, obviously, that no one can use your credentials to arrive on the clusters. We have times some people who arrive on a cluster can destroy a lot of stuff, and therefore that means that when NIC4 was, actually it's not available anymore, it's still running, simply because there was people who were succeeding to hack that, send a lot of spam to everyone and stuff like that. So that's also your responsibility. I'm not sure that's from one user that we had the issue with NIC4, but in any case, that's a bit of your responsibility. And then if this happens and someone's compromised another cluster, that means the whole clusters went down for a week. The cluster, especially impacted, can be down for much longer. So that's also your resource at the end, which is not available. So security is important for everyone, because at the end, it's our tool with which you are working, and it's not working. That's always annoying. So that's just the 2-second security. Obviously, don't share it in that.